So you all have seen this. You know what to do with it. Now, in grade 2 or 3 or 4 or 5 or 6 or 7 or whenever you did these with your previous math teachers, this is where it ended, right? You made a little factor tree. You made a little list of factors. The numbers never got very big, did they? As we discussed yesterday, numbers go up to what? Infinity. There's really big numbers out there. Sometimes we got to do math with really big numbers. Doing math with really big numbers is a pain in the rump. But we can always simplify numbers. And this factor tree thing that was the goal in grade 2, 3, 4, 5, 6, whenever it was, is now nothing but the barest minimum first step. Everybody cool? And there's a problem with the way we teach math in British Columbia, and it is just that. We teach you something in grade 4, and then you don't use it again until grade 10. And then math gets this vibe of, when am I ever going to use this? Because you don't use the basic stuff that you learned in grade 3 again until grade 10. So it seems like you don't really need it. So we are right here now. Before I carry on, we've already discussed factor trees. We've already discussed what a factor is. Now we got to discuss what prime numbers are, because we are going to use specifically factors of numbers that are also prime numbers. What is a prime number? Corey.
A number that can only be divided by 1 and itself?
Yes. A prime number has two factors. One, which is a factor of every single number, and the second factor is itself. So the first thing we need to do is make sure we're all aware of that. A prime number is a number, not a number with an E, a number with two factors. Those two factors are 1 and itself. Now, the most powerful of these numbers is the number 2 because it is wholly unique. Why? It is the only even prime number. It is very powerful. The neat thing about prime numbers is there appears to be no way to predict them, except that they are all odd numbers after 2. For example, the first few are easy. 2, 3, 5, 7. What's next? No. See what I mean? The pattern breaks down, because 9, 3 times 3 is 9. 11, 13. What's next? 17. Then 19. Then 23. Then no, 26 is even. It divides by 2. 20, 29. Then the next one's 31. Then the next one, no. 33 divides by 3 and 11. See? No pattern, right? The next is 37. Okay, so good. We're aware of what they are. Now, here is something that even if you despise math, you should think is kind of neat. A supercomputer recently discovered the largest prime number of which we know, and it's up into the billions, which to me is pretty crazy that you can go up into the billions and find a number that doesn't divide by any other number. I think that's kind of neat when you think about how many numbers there are between 0 and into the billions. The reason it's important is because it's a good prime numbers allow us to break down these gigantic numbers into numbers with which we can work. All right? And to do so, we have to be good at factoring. Because you already know factor trees, because you all know what a factor is, I don't spend a lot of time on it. But today and today only, we are going to spend time on it. Tomorrow, I'm going to show you how we use these to help us break down other numbers. Okay? So let's start with just breaking these down. Do a factor tree to find the prime factors of these two numbers. We'll do the first one together. You'll do the second one by yourself. Please remember there's more than one way to do this, so don't get upset if you don't do what I do. Just to make sure it's okay, I'm going to say this. The first level of a factor tree splits the number you're dealing with into any two factors, but you're not allowed to use 1, because 1 in 54 is that doesn't count. So everybody break 54 into two factors. You can do a lot of different first levels here. Would anybody like to say 1? What did you do? 2 and 27. Is that okay? Absolutely, because 2 times 27 is 54. What are some other ones people had? Eric?
6 and 9.
Yes, excellent. Is there any other ones people had? Yo. 3 and 18. So everybody can do this, right? Now, is either of those a prime number? 2. When we get to a prime number, we stop our branch. 27 isn't, so we continue to break it down. What does it become? You're never allowed to use 1. I did say that a couple of times. 9 and 3. Is one of those a prime number? 3. Excellent. Is 9? No, so we break it down again. What is it? 3 and 3. Now you can plainly see that I have 2 times 3 times 3 times 3. Since they are all connected by multiplication, they are all factors. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is indeed 54. Now, how is the other way we would write that? Knowing what you already knew it, but after being reminded of exponents, what's the other way we could write that? 2 times 3 cubed. Is everybody good? Aye. Do the same thing with 162. Again, there's more than one way to start. Everybody good, yeah? Yeah. Okay. Now, factor trees and what we're going to use to break down big numbers and what we're going to use to break down big expressions, which is factoring again, is really, really easy if you actually know your times tables. Now, when I say actually know, I mean they are memorized. And when I say memorized, I mean that if I ask you any two numbers between 1 and 12, you are able to say the answer without doing this. You see how I looked up? That's what your brain does to your body when you are trying to think of something. It makes you look up. It's also a good little lying tactic. Train yourself not to look up when you're trying to think of a lie. Because when you look up, that's what you're doing. Anyways, if you can do that, then the next 2 units for you are going to go by like that. Because it's going to be super easy. If you aren't at that spot with your timetables, which a great many of you are not, then it helps to have a few little tricks. I'm going to tell you a couple of those little tricks now. I never learned these tricks because when I learned how to do this, we all knew our times tables. It was memorized. We weren't allowed out of grade 3 until we knew them. So I don't have a lot of tricks, but I got a couple. Usually what happens is a kid from the class tells me some trick that I didn't know because you guys have been taught a whole bunch of tricks instead of being taught how to act, or instead of being expected to learn stuff. So, the first one is easy. 2. If something is going to divide by 2, how do you know it's going to work? Right. 2 is a factor of all evens, even numbers. How do you know something's even? How do you know? By looking at it. It ends in 0, 2, 4, 6, or 8. Automatically. And since 2 is a very powerful prime number, that means half of every single number I ever ask you to factor, 2 will work for you. Right? Excellent. 3 is a factor if the sum of the digits is divisible by 3. Here is what I mean by that. Give me a number between 0 and 9. 7. Give me another number. 4. 744. 744 is my number. I am asking you to make a factor tree of 744. Don't, just look. You know it divides by 2 because it ends in 4, correct? But also, observe, 7 plus 4 plus 4 equals 15, right? Does 15 divide by 3? Yes. So that means that divides by 3. Everybody understand? Watch. 3 goes into 7 twice. 6, 1, bring down the 4. 3 goes into 14 4 times. 12, 2, bring down the 4. 3 goes into 24 8 times. Divides by 3. Everybody understand? And that always works. If the numbers will add up to 3, you can divide by 3. Cool? All right. I don't know of one for 4, but there is one for 5. 5 is a factor when? When the number ends in 0 or 5. Automatically. And the last one of which I know is, I guess 2, because I never write down 10, because everybody knows 10, is 6. 6 is a factor if 2 and 3 are factors. It's automatic. That's going to show up in a second. Corey.
I believe the trick for 4 is that you only have to worry about the last 2 numbers. Anything before that, it doesn't matter.
Okay.
And I think 8 is the last 3 numbers.
Okay. I say memorize your times tables, because that's actually useful in other math. Memorizing a bunch of crazy little division shortcuts is useless for everything but division. But that's just me. All right. Everybody cool? Okay. Now, we're going to use 2 terms right now of which you should already know, but some people in some classes don't. First thing we're going to talk about is the greatest common factor, which we almost always abbreviate as GCF. That means exactly what it says. Greatest. What does that mean in math? Largest, the furthest from 0, right? Great. What does common mean? Used a lot. That's one meaning for it. Used between two things is what I'm looking for, right? We are all right now sharing in common the fact that we are wearing a shirt. We are not all wearing the same bottoms on our body, are we? So the common factor of clothing in this room is shirts. Everybody got it? Okay. So to have a common factor, you must have two numbers that share one of their factors. Everybody cool? All right. It's really easy with tiny numbers. Let me show you what I mean. What are the factors of 6? This is what you would have done with Mrs. Bad Crumble. 1 and 6 and 2 and 3, correct? 1 times 6 is 6, 2 times 3 is 6. Got it? Excellent. What are the factors of 4? 1 and 4, and then 2 times 2, so just 2, right? What's the only number that's in both lists? 3. 1's in every list, so we never count 1. 2 is in both lists, yes? Since 2 is common to both of them, and it's bigger than 1, 2 is the greatest common factor. Everybody good? Because 2 is common to both lists, and it's bigger than 1. Yeah? Okay. That's about the extent of the factoring that you have done up till now in most math classes. Does everyone agree? All right. Now we're going to use bigger numbers to do so. So first we remember our greatest common factor is the largest factor of every number in your group. So right now we've got two numbers in our group. The biggest number that's in both of them is the greatest common factor. Now, if you factored these numbers the way Mrs. Bad Crumble taught you with that long list like I just did, and the number's 162, there's going to be a crap ton of numbers in there, isn't there? And it's going to take a long time to figure out. Fortunately, math people have come up with an excellent shortcut that uses prime factors. And here's how you do it. You get your GCF by multiplying all the shared, please underline or highlight shared, all the shared factors. All right, so let's do that right now at the bottom of our page for 54 and 162. 54, and I'm going to do my GCFs in red, GCFs. What are the factors of 54? Well, it was 2 times 3 cubed, wasn't it? Right? The little 3 will show up in a second. That was 54. And 162 was 2 and 3 to the 4th, wasn't it? Excellent. Now let's choose the factors that are in both, that are shared. Is 2 in both of them? Excellent. So 2 is a common factor, correct? Is 3 in both of them? How many 3's? No. 3 3's are in both of them, correct? This guy has 3 to give, this guy has 4 to give. So there's only 3 of them that are shared. Everybody cool? So 2 times 3 cubed, which happens to be 54. Does that make sense? Of course it does. 54 is a factor of 54 because 54 times 1 is 54, right? 54 is also a factor of 162 because 54 times that last 3 would be 162. Is everybody good? Excellent. Now, it seems a little weird at first, but we're going to practice it a couple of times, and believe me, it falls into place pretty quickly. Now, the lowest common multiple, which I'm going to highlight in green, and I'm going to use green ink for, LCM. You already know how to do this, but you call it lowest common denominator, which is how Mrs. Bad Crumble taught you to add fractions. Again, easy peasy when you're using small numbers, right? 1/2 plus 1/3. What's the common denominator? 1/6, right? Because 2 times 3 is 6 and 3 times 2 is 6. Got it? You could also use 12, but that's not the lowest one. Everybody with me? I've already seen this. So lowest common multiple is the smallest number which has your group as a factor. So again, we use a really easy one. We used 6 and 4, right? So let's do that. 6 and 4. I want the smallest number that shares 6 and 4 as a factor, right? So Mrs. Bad Crumble would have said, and should have taught you this, let's start multiplying 6. We don't use 1. So what's 6 times 2? 12. 6 times 3? 18. 6 times 4? 24. Let's go from 4. 4 times 2? 8. 4 times 3? 12. Oh, look. There's a common number. So that's our LCM. That would be our common denominator if we were adding sixths and fourths, right? Okay. Again, super easy to do with little numbers. But numbers get big, don't they? So what we do to use prime factorization, we do this. An LCM can be found using prime factorization by multiplying every, not shared, every factor, right? But we don't care about repeats. Here is what I mean by that. We'll do the LCM of the same ones. Remember, we had 54, which was 2 times 3 to the third. We had 162, which was 2 times 3 to the fourth. I care about all of them, but no repeats. So, I have to count 2, right? Because it's in the list. Do I have to count it more than once? No, because I don't count repeats. So I have a 2. Cool? I also have to count my 3s, but I only count them once, no repeats. If I count these 4 3s down here, does that cover these 3 3s here? Yes, I don't need to count them twice. So I need to count these 4 to cover those 3. Everybody cool? Then I just do the math. 2 times 3 to the fourth is 162. And again, that makes sense because 54 times 3 is 162. And 162 times 1 is 162. So they are both a multiple of 54. Is everybody good? All right. That's how you do it. On the next page, we're going to do one together. You're going to do one by yourself. And we're going to do one kind of shared. And then the last one, I'm going to get you to do it by yourself, but it's going to be a little bit weird. Everybody go down to the bottom to D. And I don't want you to do just 35 and 84. I want you to do 35, 84, and 27. Okay? Let's start with the first one. And let's work it out. First one we have is 36 and 120. So step 1 is to find our factors, yes? You have to factor both of them. I don't care how you do it. Let's start with the first one, 36. What would be your first level, Seamus? What would be your first level? Your first breakdown of 36. 2 and 18. Did anybody else go 2 and 18? Okay. What is somebody else's first level? Raul. 6 and 6. Great. So we could have gone 36 to 6 and 6. Did anybody have a different first level? Nobody did 9 and 4? Poor 9 and 4. I'm going to do 9 and 4. Now, depending on your first level, that's going to change your second level, isn't it? This guy doesn't go any further. Does this guy? To what? 2 and 9. There's another prime number. 9, 3, and 3. Everybody agree? 6. 2 and 3, 6. 2 and 3. Hey! 9 and 4. 3 and 3, 4, 2 and 2. And I get always the same thing. 2 squared times 3 squared. Everyone cool? Now, obviously, I'm not going to do 3 factor trees for 120, right? I just wanted to show you that no matter how you start, it always ends up the same. You guys do 120. I'm assuming most of you will have 10 and 12 for your first level.
Yeah.
Can everybody get to there? Okay, now I believe I did my LCMs or my GCFs red, right? Okay, so my GCF is everything shared is 2 in both lists.
Yes.
How many 2s make it into both lists? 2. That guy's got 2, that guy's got 3. So this guy can only cover 2 of the 2s. Is 3 in both lists?
Yes.
What's the maximum amount that either number can cover? 1, 3, right there. Is 5 in both lists? No, so 5 isn't part of the GCF. What is 2 squared? 4 times 3. What is 4 times 3? 12. So what is my GCF? 12. Everybody good? LCMs I did in green. Again, LCMs count everything, but what do we not care about? Repeats. So, what's the maximum amount of 2s I can get out of this group? 2 to the third. Because this guy has 3 to cover. I got to count them all. I don't have to count the repeats. What's the maximum amount of 3s I need? 2, because this guy has to be able to cover 2 of them. That covers this guy's 1, and I don't count the repeats. What else? 5, because I got to count everything. 2 cubed is 8. 3 squared is 9 times 5, 360. Everybody good? Everybody good?
Yes. Yes.
Okay. All right. Now, you guys try B. Get at least to this point where you've got the list by yourselves. I'm going to turn off my screen so you guys can't see what's happening, but I'm going to continue to work so the video will have the whole factor tree being constructed. Everybody cool with that? Go. Is everybody to their list? If you've made it to your list, subtly tug on your left ear. This is an IQ test for people. I check how many people grab A, the wrong ear, which some people always do. B, how many people have to go left for L. And how many people just sit there like this. Proving that not only do you not know math, you also don't know your lefts and rights. Proving that I'm a little bit worried that you're all at the age where you're about to go get your N's.
L's.
I forgot, you need L's first. Even more frightening. L's for left! All right. So is everybody at their list? Excellent. So you should have something on your page that looks like what I have here, but your factor tree may not look like mine, right? Until you get to the ends of all the branches. So everybody should be here.
Yes.
Is everybody cool? You need to stop and reassess if you cannot get to here. You must reassess on your own because to get to here requires you to be able to do division, which was taught you in grade 3. Is everybody good? All right. GCF, everything shared between both lists. Is 2 shared between both? Yes. How many 2s?
One.
Just 1. Is 3 shared between both? How many 3s? Just 1. 2 times 3 is 6. So 6 is the GCF. Good?
Yeah.
Excellent. GCF is usually not a problem. It's the LCM that screws people up. Count everything only once. Do I have to count 2s? Yes, because there is a 2 there. How many 2s will account for the least amount of 2s?
3.
I must have 3, because this guy has at least 3. So I have to account for all of his. 2 cubed. How many 3s? 3 squared. What is 2 cubed? 8. What is 3 squared? 9. So what is the LCM?
70 left.
No. 2 cubed is 8. 3 squared is 9. 8 times 9 is 72.
I did that with my calculator.
Okay. Is everybody good?
Yeah.
Excellent. Now you do C completely by yourself. I am not going to say a word. I'm just going to do the work and then show the right answer up there.
I'm gonna figure out what's way. It's not long.
When you feel you have the right answer, twirl your hair.
Twiddly dee, twiddly dum.
I do. I can make a little ponytail.
Oh, like me?
Which is, ironically, proof that I need a haircut. Because as my wife says on a regular basis, the more hair I have, the balder I look. What? The more hair, the longer your hair is, the more hair that's up there, the balder I look, she feels. So as you can see, it is time for a haircut. My semi-annual haircut. I get 2 haircuts a year because I'm married with children and how I look doesn't matter. Thanks, I'm already stunning, so it doesn't matter. All right, who would like to tell me the GCF? Who's feeling strong? Eric Letty.
What is fitting?
What is fitting? And he even phrased it in the form of a question, which makes Alex Trebek a happy man.
Yes.
What is the LCM?
225.
Without even putting up his hand, he didn't buzz in, so I'm not going to answer that. He's not going to get the money for that.
Come on.
And let's wait for a buzzer.
Buzz.
Bzz.
Buzz.
Go.
What is 225?
225 is absolutely correct.
Don't steal my trend, Seamus.
If you could not do it, you must stop and figure it out. Because as I said at the beginning of this class, this stuff is but the first scratch at the first level of where we are going. So if you are already in trouble, you have to make a way to figure your way out of trouble. Okay? Okay. Is everybody good? Excellent. Let us move along then, cabbages. Do you think anything changes when there are 3 numbers? Something certainly does. You now need 3 trees. Does the method change? Of course not. 35 is what?
7.
These are super easy ones. I did this way on purpose. 27 is what?
3 and 9.
And then
3 and 3.
3 and 3. And 84 is what?
3 divided by something.
Exactly.
Hold on. I got 2.
28. What's next?
28 divided by 4.
Okay, 4 and 7. What happens to 4?
Divided by 2.
2 and 2. So what's your lists? There's 5 and 7. Correct? Excellent. There is 3 cubed, and there is 3 times 2 squared times 7. What then is my GCF?
Hold on.
It hurts me that it is taking this long to hear an answer. Seamus? No. There is, because every number shares one factor. The GCF is 1. Why?
Because not all of them share the same.
Because there is no number shared in all 3. GCFs are not necessarily always available to you. But LCMs are. What is the LCM? How many 2s do I have to cover? 2. How many 3s? 3 cubed. Then what? A 7 and a 5. And we're going to get a big number. 4 times 27 times 5 times 7. I can do that in my head, but it will take me longer than you guys will take to punch it into your calculator. What?
3,780.
3,780. That is our LCM. Is everybody Gouda? Nobody is Swiss? Lovely. Now listen to me carefully, please. It is 2:02. You are here until 2:20. I think it's 2:28 actually. But regardless, you are here that long. You are going to work on page 90, but not right now. First thing you're going to do is your exponents quiz, which I'm going to be handing out to you. Now listen to me. Do the quiz. Keep the quiz. Because just like every other quiz we've done, we will be marking it in class in a few moments. And then you will keep them and report the number to me later. When you finish this quiz, if it is not time to mark, then you do one of two things. One, you work on page 90. Two, you go back into your workbook and you look over units 1 and units 2. Because what is happening tomorrow in this room directly following lunch period? Eric? The cumulative test. Is that anything to be stressed about? No, because the worst thing that happens to you is you walk in here with a check my mark score and you walk out of here with the exact same check my mark score. What is the best thing that happens to you? You walk out of here with 100% in both measurement and trig. Should you walk out of here with 100%? Yes, because you have had numerous warnings, millions of quizzes, you have your workbook, all the videos are available to you, and I am sitting here all lunch hour tomorrow. Right? Right. What should you not work on if you are not extra confident with units 1 and 2? You should not touch this until when? After the cumulative. Because that I expect to be done by Wednesday. Clear? Good. I am going to give these out now. When you get them, put your name on them, do the work. Yes. When you finish, make a good choice about what to do with the rest of the block. All right? All right. Take one, pass them back. Notice the sassy font. It's a very sassy font. It's springtime.
Myers, did you know that chickens are cannibals?
No, they're not.
Yes, they are.
No, we have made chickens cannibals.
They're cannibals.
We have made them cannibals because of the way we keep them. Cows are also cannibals. That is what causes mad cow disease, because we are so cheap and we want so much beef that we cannot keep enough hay around to feed cows, which is what they should eat, grass. But we don't have enough land to feed enough cows to feed our beef addiction. So what we do is we grind cows up and feed them back to cows, which is why mad cow disease happened. Because the parts of the cow that us fancy pants people in North America refuse to eat are the brains and the spine. So because they do not get eaten by humans, they get ground up and fed back to the cows, which is where mad cow disease comes from. Which is why mad cow disease only happened in industrialized countries like Britain and Canada. Because in other countries, they don't bother trying to keep enough beef around to feed everybody because it's not a sustainable way to eat. They're around somewhere. Where'd they go? I made 30 copies. I can't have run out. I made 60 copies, I mean. Who doesn't have one?
I think it's us.
No, they got them.
Yeah.
There's only 2? All right. I print them for you.
Alright.
Alright,
Alright.
I'll be waiting here.
I know you will. Because where else you gonna go?
Outside.
You're good.
Oh,